Hi, in this lesson, we're going to discuss absolute value of equations and inequalities. If you're using a textbook, it's section 1.6, page 50, around page 58. Okay, so most of you are familiar with absolute value. You've probably used it quite a few times. The absolute value of 3 is what? 3. The absolute value of -3 is what? 3. It's the distance. Technically, some people think of it as the number without the sign. Some people, the true definition is the distance from 0. If we have a number line here and we have 0, we have something 3 units in the positive direction, it's 3 units from 0. If we have a number -3, it's still 3 units from 0. The distance is the same. So when we're talking about absolute value, what about the absolute value of 0? Can you do that? Yeah, it's 0 distance from 0. And again, you could think of it as a number without the sign. So that's seems pretty simple. Well, what if we had this one? What if I changed it around a little bit? What if I say the absolute value of x equals 7? Then what would x have to be? Well, x could be 7, right? Because the absolute value of 7 is 7. Or x could also be a -7 because the absolute value of -7 is 7. So in this case, x could be 2 different numbers. It could be a 7 or a -7. It's a union. It could be either of those two answers. Sometimes we call that a disjunction. Okay, what about this one? The absolute value of x equals -7. If I put a 7 in here, could it equal -7? No. What if I put a -7? No. Absolute values are the number without the sign. Here we have a sign. We can't go in -7 from 0. The distance is always calculated in a positive direction. So therefore, there is no answer to this. It's a null set. It does not exist. Okay, so no solution, no answer. All right, let's try one a little bit harder. What about the absolute value of 2x plus 5 equals 13? So if you think on this just a little bit, you might come up with the answer of 4, huh? 4 times 2 is 8. 8 plus 5 is 13. Yeah, the absolute value of 13 is 13. But did anybody think a little bit harder? Did anybody come up with -9? That's probably the first time I saw. I wouldn't have come up with this either. But -9 times 2 is -18. And -18 plus 5 is -13. And the absolute value of -13 is 13. So we get two answers. X could be 4 and X could be -9. Kind of tricky. Well, is there an easier way to do this? Because who wants to rack their brain trying to figure out how to do a problem like this? You know, it's kind of a tough one to do. So what we do is a little technique. We're going to write down the absolute value. We're going to take this out of the absolute value so that we can get a negative answer or a positive answer. So we're going to take the absolute value out. And what we wanted in here, you kind of think, is that we wanted this to be either a 13 or a -13 to come out to 13. Okay, so we're going to say 2x plus 5 equals 13, or 2x plus 5 equals negative 13. See, inside this absolute value, you could have a 13 or a negative 13. So we're going to try either one of those. And let's see what happens. Now let's calculate. Let's bring this 5 to the other side. And negative 5 to both sides. 2x equals negative 8. And of course, divide by 2. X is a negative 4. Is that correct? No, it isn't, because this should have been a positive 8 and a positive 4. Okay, that looks a little bit better. We had more positives than negatives. Okay, just trying to keep you on your toes. Okay, how about a negative 5 here? Now that looks a little bit better. 2x equals negative 18. And then we divide by 2. 2x equals negative 9. So here we have our two answers. And we just put the word or between them. So x is 4 or x is negative 9. And there's our two answers to this problem. Easy enough, huh? Okay, so you get the idea behind it. It's not really too hard. Let's try one a little tougher. What do we have this problem? Here's one. Absolute value of 2x minus 3 is equal to the absolute value of x plus 5. Okay, well, one thing I like to do, when I did this one, I kind of put the negative here and the positive here. That's okay, but you notice this came out with a negative answer. I usually like to put the negative first and then the positive. So I'm going to switch it around on this one. I'm going to say, I'm going to pull this out of the absolute value. I'm going to say that 2x minus 3 could equal negative this, x plus 5, or 2x minus 3 could equal positive that, x plus 5. Okay, so it could be the negative of this or the positive of this. So one of them stays, I don't adjust it at all. The other one I use the positive or the negative. And now what I'm going to do is I'm going to distribute that. I'm going to think of that as a negative 1. So this is negative 1x minus 5. And I'm going to try to solve it. I'm going to bring the negative 1x over. That'd be positive 1x. I get 3x. Bring the 3 over here. That'll be a positive 3. That'll be a negative 2. And so I didn't get a real great answer, but I get negative 2/3. It's probably not an answer I would have thought of. And that's one of my answers. Now the other answer would be, or 2x minus 3, I'm going to distribute a 1, nothing changes. 1x plus 5, bring the x over. This is now going to be a negative 1x. So that gives me x. And now I'm going to bring the negative 3 over. So that's going to be a positive 3, and that's going to give me 8. So x equals 8. So here's my two conclusions. X could be either a negative 2/3, that'll work in both of them, a little hard to calculate, or x could be an 8. Might be easier to see, because this would be 16 minus 3 is 13. And this is 8 plus 5 is 13. The negative 2/3 is a little harder to see if you put it in, but it would work. Okay, you're saying, well, that works great. We can solve this, but what if you have inequalities? What? Inequalities. What if you have something like 3x minus 2 is less than 4? What if we have something strange like that? That's right, we close the book and go home. No, we don't. Okay, we do the same idea. We're going to write the positive and negative values. So 3x minus 2. But we're going to write this as a negative 4. But we're also going to switch the inequality. And this is really important. This inequality is going to get switched around to greater than. So 3x minus 2, opposite, opposite. And 3x minus 2, same. See, that doesn't change. Same. So 3x minus 2 is greater than negative 4, 3x minus 2. And this will give us the right answer and an easy way to do it. So all we got to do is add 2 to both sides. 3x is still greater than negative 2. And then divide by 3. X is greater than negative 2/3. Okay, now we're going to graph this, solve this one. We're going to add 2 to both sides. 3x is less than 6. X is less than 2. No switcheroonie. Okay, if we were to graph this, well, on a number line, let's take a look and see what happens. Here's negative 2/3. Here's 0. Here's 2. So on this one, I'm saying it's greater than negative 2/3. Okay? But I'm also saying it's greater than negative 2, greater than 2. So it's going to be an open circle here, and it's going this way. But when it hits 2, or gets very close to 2, it says it has to be less than 2. It's greater than this, or maybe, and it's less than 2. Going back and forth, back and forth. See? So that's really what it's saying. It's between those two values, in negative 2 and 2. So this becomes kind of tricky a little bit, huh? And so this would give us our answer. It's between those. And if we wanted to write it the other way, we could write it this way. And what's another way we could have done this? Well, let's see if we can figure it out on this next one. Absolute value of 8 minus 4x. I prefer to do it this way because when they're greater than, it might throw you off. So I prefer to do it as 2 separate problems and then graph it on the same grid. But remember that it just kind of hits the point. The book does it slightly different, but I personally prefer it this way. So I'm going to say 8x minus 4, 8 minus 4x is greater or equal to negative 5, or 8 minus 4x is less than or equal to 5. Okay, and then stop it like that. And then let's stop it. This was an 8, it's a little sloppy there. I bring it to the other side. This would be a negative 4x is greater than or equal to negative 13. When I divide, this is by negative 4. I'm going to switch the symbol. X is now less than or equal to 13/4. This book has a tendency to not give real nice problems. Okay, now I'm going to bring the 8 over here. Negative 4x is less than, subtract 8 from both sides. Negative 3, right? So, and again, I'm going to divide by negative 4. I'm going to switch the symbol. X is, let's put the negative 4 down here, greater than 3/4. So it's less than 13/4, but it's greater than 3/4. So it's still going to be a between statement. A little hard to graph this one out. Here's 3/4. Here's 13/4. So it's less than this or equal. But then when it hits the 3/4, it's going to bounce back. So it becomes actually an and statement. Okay, one last problem. We'll try this one. I think I've already messed it up pretty good. How about if we have a greater than problem? Okay, let's put it up into two parts. I like to do a little t thing. 4x plus 2 is greater than or equal to 6, and then the opposite. 4x plus 2, and you could do the same thing on less than or equal to -6. Reminds me to switch and switch. Now I solve it. -2, -2, -8. Still less than. X is less than -2. Bring it over. Add a -2 to both sides. 4x is greater than 4. Divide both sides by 4. No need to switch. 1. So what I'm saying here is it's less than -2 or maybe equal, but it's greater than 1 or maybe equal. And then if I want to do something here, I'm going to put in an interval notation, -infinity, -2, solid bracket. And this would be an or statement. 1, comma, if you put an and, I wouldn't get too upset, but it really is. It's 1 to infinity. Okay. Now, I'm going to show you something on these absolute values. If they're less than the absolute value, say less than b. If it's less than some number, it's always like, I don't know if you can see my arms, it's always like in between. It's cold. Let's see if I can make this bigger. I don't know. I can't. I don't know. There's a way. Move it over a little bit. There you go. Okay. If it's less than, it's like cold. It's always between. It's going to look like this. Cold. And if it's greater than, it's always like, I'm stretching out. And that always holds up on these. You see, kind of think of this as the, I don't know, chicken problem. It's supposed to be a chicken spreading its wings, and this is a kind of the, I don't know, guy, I don't know, funny face. All right, so greater than, less than, and they're always going to be like that. Greater than. It's going to look like that. Should have had the head going the other way up, and then the chicken. All right, well, think about the chicken and the egg and see what you can do. All right.